Let's look at some more pieces of data we can collect from a graph of a function. We've already looked at some pieces of a graph. This is a continuation of that same lesson. This should be the second video. You've still got a copy of the notes in front of you that you're taking those notes on. Let's take a look at this graph in particular. So the graph shows the population of a deer, population is Y, X years after it is introduced on an island. So this graph, my X is my time in years, my Y is my number of deer. Going back to what we've talked about before, this is a non-linear graph. We have an x-intercept over here, which shows us that when there's no deer at about year 5.5. And at year 0, we have about 80 deer on the island. So our y and our x intercepts. And it's not symmetrical, so I can't really talk about or interpret its symmetry. Some other pieces of data, and you'll notice there's a lot of writing here because we're identifying and interpreting. So this is kind of bringing the English into this. We're explaining the story is what we're doing with this data. So we're identifying the data, but then we're also using it to tell what's happening in this particular function. We're going to talk about when the graph is positive. We're going to talk about when it is negative, and we're going to interpret that. We're going to talk about when the graph is increasing and decreasing, and then we're going to interpret that. We're going to talk about the relative maximum and the relative minimum, and we'll interpret those. And then we'll also talk about the end behavior. So let's get started. So when is this graph positive? We talk about the graph being positive when the line of the graph is above the x-axis. So for most of what we're looking at here, the graph is above the x-axis. So we can say that the graph is positive between x equals 0 and x equals 5.5. So notice this is a vertical line, x equals 0. If I graphed that line, I would get a vertical line. And I'm kind of describing the graph in between these two vertical lines here. That's perfectly appropriate for what we're asking for, and that's the best way to describe where on the graph we're looking. When is it negative? Now this line has an arrow on the end, so it's definitely saying, well, we're going to continue here and see what happens. So we could say that it's negative for x is about larger than 5.5. Now, we're talking about the deer population, so the deer population is never going to actually be negative. But if we look at the graph and we see that it's got a line showing us this is continuing, well, we know it would go into the negatives after 5.5. Let's actually interpret that now. So we have some numbers. What do those mean? This means that there were deer on the island for about 6 years. So we started at year 0 with some deer on the island, and then at about year 6, they were gone. We've just interpreted those numbers. Increasing and decreasing. So now we're looking at when are parts of this graph either increasing on the y-axis or are they decreasing on the y-axis. Again, we're going to describe those as far as a vertical line on the x-axis. So it's increasing. You'll notice it's increasing here from about x equals 1 to about x equals 4. So that's how we're going to describe it, between x equals 1 and x equals 4. When is it decreasing? Well, it's decreasing here when x is less than 1. And it's also decreasing at the end when x is greater than 4. Not the only ways you could describe this. There are definitely other ways you could word this, but you want to get across that point that you're describing a section of that graph. Let's interpret that. This means the deer population decreased for the first year, increased for the next 3 years, and then decreased after year 4. So it decreased, increased, and then decreased again, explaining specifically when that happened. A relative maximum and minimum. So we're going to look at points in the graph where we seem to have a pattern, and then suddenly it either gets to its highest level and shifts to and starts decreasing, or it's going down, gets to its lowest level, and then starts increasing. So we have one relative maximum here up at the top, and that relative maximum is about x equals 4. We have a relative minimum of about x equals 1, here where my line comes down and then starts to go back up again. So it's a relative minimum. It's not maximum or minimum over the whole graph, but it's relative to this particular point, to this particular part of the graph. Let's interpret that. The extrema of the graph, these are the extremes, the extrema of the graph indicate that the population experienced a relative low at year 1 and a relative high at year 4. Now clearly this is not the lowest the population experienced ever, but relatively at that time it was experiencing a low. And the last piece we're going to talk about is the end behavior. So this is our last piece here. And we're going to look at what seems to be happening in the future. So what could we kind of see is going on at the end of this graph? What do we think might be happening? And the population decreased to 0 after year 4. So we got to year 4 and then it went down to nothing. So at the end of this graph, what's happening at the end of this story, we decreased down to no deer. So we've got all these pieces of our linear function from the graph. It's not a linear function, it's just a function. We have all these pieces of this function that we can identify and then we can also interpret.